So welcome. Let's have a look at this second one. So this says a 5 meter long rod is positioned with one end at +4 and the other end at +9. So now this is a bit more general. This is at +4 and the other end at +9. And the rod is uniform with a mass, big M equals 6 kilograms. Using the method of thing, where is its center of mass? So here we'll turn around and say, okay, well, we know that our center of mass is equal to the integral of R dm. R of our center of mass is equal to an integral of R dm over big M. And again, I know that, well, okay, if this is dr, that goes with dm. So I go, well, dm is equal to the width dr times the linear density, because it's a uniform rod. So dm is going to equal to dr. It's going to be the total mass over the total length. So I take that and I substitute it into there. So this equals the integral of R M over L dr over M. And then I can take out all the things that are constant, so it's going to be M over L divided by M, the integral of R dr. So it's the same as before. Cancel out, so my RCOM is equal to 1 over L, the integral of R dr, which equals 1 over L R squared over 2. Now I've got to put in my limits. And if I was to ask you, because this is the skill now, what are the two limits? What numbers would you put in? What would you write down? Anybody want to help me?
9 and 4.
It would be 9 and 4, yes? It would not be the separation, which is 5. Here, it was L because we started at 0 and we ended up L units away. But if we don't start on 0, then our limits are not 0 and L. They're basically, if you like, from the origin to the nearest bit, and from the origin to the nearest bit plus L, if you want to express it like that, yeah. In the book it goes A and A plus L, because I want to use letters some more. At this point, I'm like sick of letters, so I'll go from 9 to 4. So then I'll turn around and say RCOM is equal to, and I've 1 over L, and let's just put numbers in now. So 1 over the length is 9 minus 4, which is 5. So I have 1 over 5, and then I'm going to go 9 squared over 4, 9 squared over 2 minus 4 squared over 2. So our center of mass is equal to 1 over 5. It's going to be 81 minus 16, which is 71, 65. Which equals 65 over 10, which is 6.5 meters. If you think about it, the middle of 4 and 9 is 4 plus 2.5, which is 6.5. It's a trivial answer, isn't it? It's kind of like we know the answer just by intuition from our conceptual stuff, but it's mathematically showing it. And the reason why I want to do that is because this next one will not be the same. By the way, this also is the skill you're going to use in Physics 2 when you're finding the electric field at various points near a rod of charge. So we're building skills here, and they're going to use those skills later and later. So this is where I want to go, which is a plate of charge. Sorry, a plate of mass. It's a uniform plate, so I don't need to worry about the volume of it. I can think in terms of area. Okay. I say a 5 kilogram sheet of metal is shown, so big M, I'm not going to use that diagram. And I know that M is equal to 5 kilograms. Using method calculus shown in class, show that its position is at 2. So this is 0 to 3 meters. I'm only dealing in the x direction, the x coordinate. So I'm going to just do the x coordinate. I can only do one at once. I do need to know what the y coordinate is. I need to know that that's 4 up there, 4 meters, because I need to know the area of the plate. I'm going to say, well, my R center of mass is equal to the integral of R dm over M, but I don't know how to do that. So I go, well, let's have a look. This is dr, and this is dm, whichever way around you want to do it. I'm looking at that slice. And I say dm is equal to, it's a mass. It's the mass of that slice. And it would equal the area of the slice times the area density. Does that make sense? It's not linear anymore, it's area, yeah? So it's the area of the slice, not the width and the length, but the area and the area, yeah? Because I'm dealing with a little bit, yeah? So dm is equal to, well, the area is going to be dr times, well, I don't have a thing for it, let's call it h. I'm not going to worry about it being a trapezoid. I'm going to make the slice so thin, the difference between the left-hand height and the right-hand height is going to be insignificant in the limit when I integrate. So I'm just going to call that times h. Yeah? So there's my area. And then my area density would be the total mass divided by the total area, which is a half. And again, I'm going to try and keep letters a little bit longer, so I'm going to call that x. I'm going to call that y. So half x times y. Okay? Mass is a constant, I know it. X is a constant, I know it. Y is a constant, I know it. H I got no idea about. And H varies. I can get H by using the equation of a straight line. That H, I can say H is equal to slope x plus b. Agreed? Y equals mx plus b. So h is equal to, what's the slope in terms of y and x? It's the rise over the run. And this x position, I shouldn't, this is little x. So there's little x along there, which I'm going to actually call little r. There's my r. So I'm sorry, I'm changing all my letters on you. But we're going to call that little r. Not the total length, but it's just the r that I'm integrating with respect to, plus 0, which equals y over x times r. So dm is equal to dr y over x r m 1/2 x or y. And just letters, which equals, save your dr for later. We have little r, we have big M, dr, and then the y cancelled out, so I can forget about that. I have 1/2 x squared. So I got my dr's in there, my y cancelled out, my little r's in there, my m's in there, my x is in there, my x is in there, my half's in there, and my y's got cancelled out, which gives me 2m r dr over x squared. Okay, so let's take that. And again, if you try and remember all this, good luck. But physics-wise, you know what you're doing. You know, I mean, you say, oh, I want to have that divided by that. I want the mass divided by the total area. I want to use a straight line. So if you know your physics way, then it just falls out. So our center of mass is equal to the integral of r. And then I'm going to have 2 big M r dr over x squared, all divided by m, which equals, your m's cancel. So I have, let's just take it out, m over x squared, those two go out, m integral of r squared dr. It's an r squared function now. So our center of mass is equal to 1 over x squared. That's going to be r cubed over 3. Is that right? Yeah. And it's going to be from 0 to x. Again, we're starting on the origin this time. So 0 to x, which will give us 1 over x squared, x cubed over 3 minus 0 cubed over 3. Our center of mass is equal to, I lost a 2 somewhere. There was a 2 there. I'm so sorry about that. It's really annoying when that happens. 2. I forgot to bring that 2 across. 2, which gives me 2 over 3x, which in this case is 2 over 3 times 3, which equals 2 meters. Now, we didn't expect it to be in the middle because there's more on the left-hand side, on the right-hand side there is on the left-hand side. So we knew it was going to be between 1.5 and 3 meters. But we didn't know it was going to be 2 meters. And it turns out for all triangles, you get 2/3 of the way along from the little end to the big end is where the center of mass is. Just comes out of the math. So let's just review. I did my diagram. I wrote down my principle. I recognized I have no idea how to integrate r with respect to dm, so I need a conversion. I recognized it was an area, so I drew out my slice, and I just did physics on it. I just said the mass of that little slice is equal to the area of the slice times the area density. of the triangle. So then I shove values, I shove dr and h in for the area of the slice, and I have m1/2 xy for the area of the triangle. And I need to find something, because h changes as I work my way along. Imagine the slice is working your way along, it's getting taller and taller and taller. So I realize y equals mx plus b, so I shove in my terminology for that, and so I end up with this more complicated thing at the end. Just letters and numbers though. Then I substitute in like I did before, and I do my calculation. I just got to check and see what my limits are. In terms of memorization, that's a pain. In terms of waypoints in the physics, you're kind of just doing one extra step. Before you did the area density, you did the linear density, and now you've got to take into account the area density, and you've got to take into account the fact that the height changes. That's just one extra step. I'd love it. It won't be a test question, but I'd love it if I could give you. Sorry, you got a question. I'm sorry.
Why wouldn't you use like the slope as 4/3 instead of?
Oh, you can. No, you want to put numbers in. You can put numbers in anytime you like. As I said, I'm trying to model for you, keeping away from numbers a little bit longer. But yeah, you can put numbers in as soon as you like, and they'll all cancel. So it looks like it'll be fewer steps, but again, you can't check it so easily when you're viewing it. And for learning it, you kind of don't see the pattern so easily. So yeah, feel free to put numbers in a lot earlier than I do. You know, it's fine. I'd love it. Supposing I said to you, it's not a triangle. Supposing I said to you that it was a kind of parabola, and I gave you a squared relationship, and I gave you that y is equal to x squared plus 2. Then down here, you'd have your height would not be y equals mx plus b. Your height would equal x squared plus 2. So it'd be the same problem, you just have a different conversion thing there. And if you know how to do it, I can give you any function and you can do it. I'm going to give you the triangle, but I can give you any function and you could do it. Yes?
I had a question about why you squared the r in the integral underneath the regular graph.
So,
Like the very first graph, it's when you pull out all the constants and you have like the integral of the r squared.
so there or there?
There, yeah.
So here, because we had an r from our original equation, and we have an r from our conversion. Yeah. Yeah. Cool. That is going to be on your test. I'll change the numbers. But that's going to be on the test. And I want to see the diagram, the equation, this conversion bit. I'd love it if you said, h equals equation of straight line, just information. I'd love it if you really showed me. I know the steps, because then my sense is if you know the steps, you can do it. Okay, I'm going to skip that one because I want to get on a bit. Okay, let's get out of here. Let's stop.